Okay, good afternoon, students. This is Mr. Gee. Yesterday you should have completed Worksheet 2.1a, and this should be Tuesday, August the 30th, and you should be completing what is Worksheet 2.1b. Yesterday we did A, and hopefully that went okay and you got your assignment turned in. So the drill today, you'll do the same, basically the same thing that you did yesterday, you'll do today. So hopefully we'll do okay. Most of them we're going to do. The last page you're going to mostly do yourself, and you'll use this diagram up here, and you'll use this paragraph right here to help you with the back side of the page. I'm going to go ahead and put my name in here. You can go ahead and put yours in there. The date is August 30th, 2011, and since I'm going to put this as period, let me delete that. Put this as period, 6th period, or 5th period. And the score, I don't know what your score is, do you? But hopefully you'll get 25. So let's go ahead and read the directions. It says the real numbers consist of 5 classification or numbers, sets of numbers. So you've got the reals, you've got the rationals, which is bigger, the biggest set of the reals. Is not really the biggest set, but we can think of it that way. Integers belong to the rationals, whole numbers belong to the integers, and the natural numbers belong to the whole. And what you've got to remember, if integers is a subset of the rationals, the whole numbers are a subset of the rationals, and if the natural numbers are a subset of the whole numbers, the natural numbers are also a subset of the integers and the rational. Now if you look over here, the irrational and the rational numbers, they are not subsets. They don't have any members. None of the members over here have any members over here. So these are separate sets. But all these numbers belong to the real number set because they can be graphed on a number line. So the following is true. The natural numbers are a set of the whole numbers. The whole numbers are a subset of the integer numbers. The integer numbers are a subset of the rational numbers. The irrational numbers and rational numbers do not intersect. And this is what we see over here. The rational and the irrational numbers are subsets of the real numbers. And so that's what this diagram is showing. So let's use the diagram to the right to answer the following questions. Write true or false for each of the following statements. If the statement is false, explain why the statement is false. Okay, so let's go ahead and do this. So we got a -1 belongs to the whole numbers. And so as we do these, you've got to think about what members belong to each set. And if you think about a negative number can belong to the rational or the integers, but it can't belong to the whole. The whole numbers start with what? They start with 0 and then they go up according to the counting numbers. So this is really false. And so what do we want to put for our reason? A -1 belongs to the rational or integer numbers, not the whole numbers. Okay, that'll be fine for a statement. That's our reason. Now number 2, let's go down and do it. So what you got to think about this one is if you take a -6/3, it is a rational number because it, and if I simplify it, I get a -6 divided by 3 gives me a -2. That makes it an integer, but we know that whole numbers do not contain any integers or negative integers, and they don't contain any rational numbers. So this one is also false. Anybody can think of a reason why? Well, let's write down a -6 divided by 3 is a -2, and a -2 does not belong to the whole numbers. Okay, I think that's fine. So take a minute, go ahead and write that down. If you need to, have the substitute pause the video. Okay, square root of 25 belongs to the natural numbers and the irrational numbers. Yeah. let's take a look at this. You don't need to write this down, but let's kind of think about it. If I take the square root of 25, I can't make the square root sign, so that's the way I have to do it. The square root of 25 simplifies to 5. And if you think about that, 5 is a natural number or a counting number, and 5 is a rational number that can be written like 5 over 1 or 10 over 2. So the answer to that one is true. Okay, so that answers number 3. Let's go down to number 2. So the square root of 2 belongs to the irrational numbers. That's a true statement, so we'll just write true there. That should have been an easy one. Okay, let's go down to number 5. Okay, 0 belongs to the whole numbers and irrational numbers. Well, irrational numbers, remember, they're a number that cannot be written as one integer over another. But 0 can be written as 0 over 5, 0 divided by 6, 0 divided by 1, and so forth. So this one is false. And what's the reason? Irrational. Well, let's think here a minute. Let me write 0 can be written as an integer divided by an integer, so it cannot be an irrational number. Okay. Okay, I'm going to let you do number 6 by yourself. What you've got to remember about that one right there is the fact that it is it's a decimal. So remember your rules concerning your decimals. Number 7, I'm going to let you do that one by yourself, and what you've got to look at this number right here and realize there's no decimal point in the front of it. Okay. Alright, let's go down to number 8. Turn on my typewriter again. So negative 0.35 or negative 35 hundredths belongs to the integers and the rational numbers. Well, if you remember the set of integers, it starts like starts at 0 and goes to the right with the counting numbers like 1, 2, 3, and then it starts and goes to the left with the opposite of the counting numbers, which would just be like a negative 1, negative 2, negative 3. Well, if you look at a negative 3.5, it is actually a rational number. So a negative 3.5 cannot belong to both of these and only can belong to one. So it has to belong just to the rational numbers. So this one's false. See, I got to turn on my typewriter. So a negative 0.35 does not belong to the integers because the integers is the set. Now I'm just going to label out the set. So let's start with our curly braces. So I've got a negative 3. Oh, I need my ellipses first. 1, 2, 3. Negative 3, comma, negative 2, comma, negative 1. Negative 1, comma. I've got 0, comma, 1, comma, 2, comma, 3. And then my ellipses. Okay. So a negative 3.5 does not belong to the integers because the integers is a set. And there we go. I'll let you do number 5 by yourself. Turn off my typewriter for a second here. Negative pi belongs to rational numbers. You do that one by yourself. Let's go down and we're going to do number 10 by ourselves. Number 10 is very close to number, well, I can't remember what number. I think it was number 1 or number 2 or 3 or something. So negative square root of 49. Now if you take the square root of 49, a negative square root of 49, let's ignore the negative and let's just take the square root of 49. Well, the square root of 49 is 7. Then we apply the negative. Really what this question is asking, negative 7 belongs to the whole integer and rational numbers. Well, does a negative 7 belong to the whole numbers? No. Does it belong to the integers? Yes. Does it belong to the rational numbers? Yes. So this one is false. So let's come over here and we're going to write the square root of 49 simplifies to 7. And negative 7 belongs to the rational and integers, but does not belong to the whole numbers. Okay, that'll be great. So look at number 11. Point 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is an irrational number. Well, you can see it's got a repeating decimal and it also truncates. In other words, it ends. It doesn't have the dot 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 behind it. So it does have a pattern and it does truncate, so is an irrational or rational number. Well, it's only an irrational number, isn't it? So this answer, the statement is false. And so let's go ahead and put here. I'm not going to type all that number out. So this number truncates or terminates, can't spell, and also has a repeating pattern, so it is a rational number. Okay, there we go. Now I'll let you do number 12. Okay, let's go down to the back page, and this goes along with the paragraph at the very front that I referred you to. So if you look at this one, it says the whole numbers are a subset of the natural numbers. Is that true or false? Well, that's false, and let's go ahead and fix it. It's the other way around, isn't it? The natural numbers are a subset of the whole numbers. So that's the correct statement there. Let's go down here. Let's look at number 15. The rational numbers are a subset of the irrationals. That's also false. The rational numbers and irrational numbers, the set of rational and irrational numbers do not have any identical members, right? They're not subsets of one another. And I think if you go up here to the top, it says here the rational and irrational numbers are subsets of the real. Let's look at the statement before it. The irrational numbers and rational numbers do not intersect. In other words, there's no members of the irrational numbers that are a set of the, there's no members in the rational numbers that also belong to the set of irrational numbers. That means that's the idea that they don't intersect. And I know you guys haven't had much about talking about sets. So the rational and irrational numbers do not have or do not intersect. Need the N in there. And really what it means to intersect, it's where there's common members. So the rational and irrational numbers do not have any common members. The whole numbers are a subset of the integer numbers. That's true. Because remember, the whole numbers are 0, 1, 2, 3, 4, 5, 6, and so forth. And then the integers are the same thing as the whole, but it has those opposites of the counting numbers. So this is true. Okay, I'm going to go down and I'm only going to do one of these. The rest of them you can do. It's really hard to kind of type this stuff using Adobe into here. So we're going to go down and do let's go down and do number 21. So it says use the number lines below and graph representations for the 5 sets of real numbers. So let's go down here to the integers. So I'm going to put 0. Well, let's start here. We got 0 there, and then I'm going to go this way, and then that to the left and to the right. So I'm going to come down here, and I'm going to go ahead and start with a -3. And I've got a -2, -1, and then what will the next one be? A 0. And I'll have a 1, and then a 2, and then a 3. So basically what you're going to do is just put your numbers down at the bottom of each one of these, and like the whole numbers you'll start over here, and then with the natural numbers you'll start over here because they don't go to the left, the positive side. The rational numbers, you can choose decimals, fractions, integers, and just give me a range of numbers for that one. And now the irrational numbers, you'll just have to be very, very selective of what you use there. Now the handout that I gave you the first day that we talked about this on Thursday will help you to do these number lines. So remember, this assignment's due at the end of the period, and I kind of gave you some examples of what to do, and make sure you turn it in, and I will see you tomorrow. Thanks.